Guys, let's get started. So ITS 372, right? So system administration. So this is the second week. It's a short week. So we're just working on lab. So uh, today we're going to continue our looking at Linux, and we're also going to look at Python. So today is going to be kind of a review for those of you that haven't taken Python, maybe. But it's pretty straightforward. And so the idea is, how do we automate things in system administration of the Linux operating system, right? So we're going to look at basically a few libraries. And, as we start doing examples, it'll be very easy things. And, we'll start doing things to the operating system, getting information from it. And then from there, you can start to think, okay, how can we automate a whole bunch of things in system administration? If you remember, I said, for almost every topic, I will try to provide, okay, this is how we do it manually, typing the commands in Linux, and this is how we would automate the process now by writing some Python scripts, okay? So that's on the agenda, so should be, it's very important. I can't, you guys keep hearing about artificial intelligence, and you can see how you can eventually use artificial intelligence to basically write these scripts and provide, sys administration. So you are competing with AI a little bit here. And my goal is to kind of show you how this will be done, and you should be able to see it. So a large language model like ChatGPT can be asked and brought in actually into these scripts, and then be given the tools to do some of these tasks. Okay, so we'll start with the very basic stuff right now. And I know this is not an AI class, but I will at some point show you, because it's easy, actually. It's very straightforward. We use an API. So I'm sure you guys have heard of an API. And basically, we can get a token from OpenAI, bring in ChatGPT, and ask it to do a couple of things for us. All right, but anyway, let's start with the basics. Let's get Python going. So we're going to start our virtual machine here. And then all semester we'll be doing this. We are at this also going to cover a case. I like to do cases in this course. So we're going to do something from a book, a famous book called The Cuckoo's Egg, I think it is. So I'll kind of read the case for you guys. It has to do with hacking back in the 80s or 90s, I think. But it'll be your homework assignment, basically, to play with a little bit. It's very easy. All right. But anyway, and we'll talk about the book, because actually that book, we have to discuss it in this course because it's got an ethics component, right? So about hacking and things like that. And so although I'm not making the book required, I'll probably just provide a link to a YouTube video somewhere that you can just watch that summarizes it. But we have to discuss it from the point of view of ethics. Okay. The ethics, obviously, of the hacker, and then the ethics of the system administrator who tracked down the hacker. All right, so whoops. Let me get into the CVM. But today is kind of just the beginning of this whole process. So we're going to start with what is a variable in an if statement and go from there. Okay. So I'll be using the nano editor. Before I forget, are there any questions about the homework or anything? I know someone emailed me that they couldn't find the homework. It should be there, right? So I'll point that out again. And so the signage. But just for whoever asked the question, so bright space, ITS 372, content, and then should be under intro. And as we discussed, and it was in the video and everything, right? This is your homework assignment, correct? No doubts there? Okay. Anyway, so let's take a look now at the next module, table of contents. So this one, as you can see, scripting and case. So I've already loaded the case. Here I provided just a Word document. You can read it for your own reference, although nowadays there's so many blogs and posts and things. on Python, so you can take a look. I even have a series, by the way, I should point out, if you're uncomfortable with Python for whatever reason, which you shouldn't be, and you feel that you must have a proper course, I have on the channel a playlist, and you can go from a previous, when I taught 140 of Python, so you can refresh your knowledge by watching those videos if you would like. All right, otherwise it's fine. We're doing this one this week, so we just have class today. So this is the cuckoo's egg. As I said, this will be your homework assignment. I will help you to get started with it, but it's pretty easy, right? So I guess I can start here kind of to illustrate how I like to proceed. So usually these cases are going to be some system administration problem, usually security, and then it's going to involve solving this through Python and Linux, basically, is going to be your operating system. And that kind of gets you to practice. So let's read through the problem itself. So setting the stage for your first Python program. So this is the cuckoo's egg, as I said. It's based on a book, famous book. And it's a novel, so you can read it if you're looking for something to read. So a system administrator at Lawrence Berkeley National Labs, Clifford Stahl, documented his personal hunt for a hacker, a KGB informant who broke into various United States National Research Laboratories, Army bases, defense contractors, and academic institutions. In his book, The Cuckoo's Egg, tracking a spy through the maze of computer espionage, and it's from 1989. He also published a May 1988 article in Communications of the ACM describing in-depth technical details of the attack and hunt. So the attack itself is not, by today's standards, pretty straightforward. The solution is pretty straightforward. But again, the point is to write a Python script, right? You're very first. So fascinated by the attacker's methodology and actions, Stoll connected a printer to a compromised server and logged every keystroke the attacker made. During one recording, Stoll noticed something interesting, at least in 1988. Almost immediately after compromising a victim, the attacker downloaded the encrypted password file. Okay, so this is something that we're going to learn about in today's lab is where is this file? So we're going to learn where passwords and usernames and everything are stored in the Linux operating system. So the attacker downloaded the encrypted password file. And so the question is, what use was this to the attacker? After all, the victim systems encrypted the user passwords using Unix crypt algorithm. However, within a week of stealing the encrypted password file, Stahl saw the attacker log in with the stolen accounts. Confronting some of the victim users, he learned they had used common words from the dictionary as passwords, right? So this is a classic password cracking scenario. Upon learning this, Stoll realized that the attacker had used a dictionary attack to decrypt the encrypted passwords. The hacker enumerated through all the words in a dictionary and encrypted them using the Unix crypt function. After encrypting each password, the hacker compared it with the stolen encrypted password in the file. The match translated to a successful password crack, right? So, and this is some information of, and I'll demo some of this, but this is just some additional information to solve the problem. Consider the following encrypted password file, as you can see below here, which is exactly what passwd looks like in Linux. The victim used a plaintext password, egg, and salt equal to the first 2 bytes or HX. The Unix crypt function calculates the encrypted password with this function given the password and these 2 characters, and then produces something that looks like that. So, and then these are the commands that we will look at basically. So now the problem is, let's use this encrypted password file as an opportunity to write our first Python script, which is going to be a Unix password cracker. Does this make sense, guys? Pretty clear? All right, so this will be your homework assignment, as I said, but I will walk you through some aspects of it. And obviously, we're going to do some scripts today to practice. And a few other things. All right, so we have this in mind. So the first thing, let's go now to the virtual machine right? And we're just going to look for this file. So you've already practiced, you already know several things, right? You know that this $sign has meaning. This is the terminal, but it also tells you what kind of permissions you have. So currently you're a regular user. Then we have the command cat, which is a command that we can use to concatenate, but also to view the contents of a text file. So you've seen this already in practice. We know that this is the this / indicates root. So it's the root of the file directory. Then after that, we know that there's a subfolder in there called etc. I've mentioned already that this is where you store configuration files. Password makes sense to be in there. And then passwd, this is a text file that holds user information. So all the Unix user information, including the seed account and everything, are here. Okay? And there's something else called a shadow file, and that's where the encrypted passwords are stored. So there's actually two files involved in user and password authentication. So we'll look at that in Linux. And then this here, as I have these in front of me, are basically the entries in the file. So once you do cat, you would get basically, I don't know, 150 at least rows in that text file. Each one of those rows is an account. So for instance, here we have an example. We have victim as an account. So maybe this would be seed. And then root, which, root account. Although by default, this is disabled in Linux operating systems. And we'll talk a little bit about that later. It has to do with principle of least privilege, access controls, accountability, auditing, and things like that. So various reasons why you don't need to have the root account enabled. All right. Things are separated by colon, as you can see, all the entries. So here you can see it's actually has the password in there, and that's something that you can do. If you put an X in there instead of a password, then it tells the operating system that the password is not here, and instead it's an encrypted file located in the shadow file, which we will look at, which is a much more restricted file. So password is more available because there are several several programs, I should say, that sometimes need to come in here and look at the user and see where their folder is located or something like that, right? So it's less restricted, and then the actual shadow file, which contains the encrypted passwords, is more secure and restricted. So here we have several other things. You can see it's got the name, Marcus Hess or something like that. It's got basically where the programs of this person are located, also their home directory. So you can see it says /home/victim. That's their home directory, and so on. Does that make sense? Any questions? Nope. All right. So yeah, so that's the general idea. And like I said, so you can see the question is, write a Python script to address the case. You do not have to use the actual passwd and shadow files in Linux. You can just make up your own text files that follow similar format. But if you want the challenge, you can totally do it with the shadow and passwd. It's just harder. So if you create your own files, you can create your own passwords in there that are encrypted. It's just going to be easier. You're going to match something and so on. All right. So anyway, it's a password cracker. So at some point at the end of class today, I will start solving it and walk you through and just leave it for you to finish. Okay? So that's kind of the idea. All right. So I like to kind of do these things at these cases. So now that we've covered that, basically, we're going to look at my guide here where I have some things to do. So, we're going to write a Python script to gather 10 pieces of information from the operating system. And I'll indicate what's the homework assignment, basically, because I usually just demo this. So as discussed in class, write a script to iterate through the entire file system and find the path of all files containing a particular input string. Write a script to read in the passwd file from Linux, search its contents, and print out the information related to accounts such as root and seed. Implement a port scanning. Okay, so I don't know that we'll get to this one. We might do this next week. All right, so this is a short week. But anyway, so let's go ahead then. And before we get to these problems, let's just start with the basics, right? So for that, we need to go back to the virtual machine. So I started the VM. So let's open up the terminal. So remember, this is how we want to learn how to navigate the operating system. Be using, let me move this screen. Okay. All right. So let's kind of remember how we navigate through this. Okay. If you want to know where you are, you do Pwd. So home C. We know that the desktop is in there, so we want to navigate and have all our files in the desktop. I'm going to do a clear /L. And now we can take a look at the folder that I have created from last week. So I'm going to do CD ITS 372 Spring 2025. Okay. So this is going to be our folder for the semester. And so far we've done the little hello world example, and I think I downloaded that index file with wget, right? One of the Linux commands we covered last week. Any questions so far? All right, great. So now I'm gonna, create a folder here. This is week 2. So mkdir, and I'm just gonna call it basics Python. Okay. And this is going to be our current folder. So I'm going to cd into it. Clear. All right. So let's go ahead then. And by the way, remember, all these scripts are in the GitHub, of course, GitHub, so you can follow the link basically and get all the scripts that you want from there. So they would be under the basics folder. And like I said, today we're just going to do some very basic things. So let's start with so the basics. Let's just write a script, I suppose. All right, so I'm going to use nano, right, as we saw before. Let's actually call it basics.py in this case, right? And here we are. So one important library that we'll be using is something called OS. We're also going to be using another library called subprocess. So this is how you add libraries, right? And the power of Python is really here, right? You have so many libraries for various other things. Just to give you an example, later in the semester, maybe next week or in 2 weeks, we'll use another library called Scout for networking, actually. All right, and then I usually like to add some comments or something just to separate things out. So we've already done the hello world example, but what's important here is if we make the programs executable, we want to add this thing called a shebang, which goes up here. And it basically just indicates whenever you run the program where the interpreter is located. So it's going to be in the file system under user / I think it's bin /env Python. And this is probably a symbolic link, Python 3 or something like that. All right, so let's try and run this. Okay, just to make sure it runs. So this is kind of what we did last week. So I'm going to need for this to be executable. So I need an X to appear here. So if you remember, we can do that with chmod plus X, which is a simple solution, basics. Okay. We look at it again, and you can see the X's have now been provided. So that means we can run this program. and then we just run basics. No errors. Did you see that? So it ran perfectly fine. We loaded the libraries. I can also just do Python basics, and that works perfectly fine as well. Any questions? Does that make sense? All right, so that's essentially running a script. Let's go back to the script itself. So we've done the print. We know how to print. Now let's do let's just create a variable here. So I'm going to do var1 equals 7. If it was a string, just do something like that. But it's let's say a number 7, and then var2, 3. So then result is equal var1 plus var2. And then we just printed. Like that. Does that make sense, guys? Pretty easy stuff, as I said. Then remember, Control X, Y, enter. Now we run it, and it says that's 10, and we know it's working. Okay? So that's, this scripting part is very straightforward, really. There's nothing all that challenging with this. All right, so now let's go back to the script. And now let's just add a couple of if statements or an if statement. So to do an if statement in Python, you can do if res less than 6. So notice we use a colon at the end, right? Instead of curly brackets like in C. And then instead of curly brackets, we use indentation. So that's the key thing. So enter. So that means either tabs or spaces. Yes. Go ahead, please. Comments, you just need one and then you can add more. So for instance, I hear what I wanted to do is a line. So essentially the first one's a comment and then after that is anything. So this is enough for a comment. I have habits. So I do things like this just because I've just gotten used to it. I may do 2, but 1 comment should be it. Yeah, a colon is after if statements and for loops, as we will see, you add this colon. So it's a combination of colons and indentation instead of curly brackets. That's the trick. That's the hardest part, actually. Right? You can do tabs. Also, just don't mix them. If you're using tabs, don't mix tabs and spaces. So choose one. Because it'll give you can't see them, right? So you're not going to know what's there. Word wrap. Like how you should never write anything that's longer than like this, really. So your code is going to be short. Oh, you wrote yeah, just okay. You mean like that, several sentences?
Yeah.
You can do this then. Yeah, I think this is single quotes. So 1, 2, 3. 1, 2, 3. Is that what you meant? Yeah. Yeah. So you can do that. That's another style of comments when you're doing that several lines. And you don't want to add all the pound signs. Any other questions, guys? All right. Yeah. So as I said, just a review. So the trick with if statements and for loops, instead of curly brackets, 2 things. Colon and indentation. So what I mean by that here in the next line, I, as a practice, like to add 4 spaces, just it makes it easier to read. So I'm going to do 1, 2, 3, 4. And then I can start writing the next statement. So for instance, for this one, I just say print less than 6. Just like that. Else, and notice, again, the statement else has a colon at the end, and then indentation. 1, 2, 3, 4. If these are off by one space, it's going to give you an error. This is the hardest part of this whole thing. Yeah, it's a habit of mine. So some people do 2, but I find that not easy to read. So, it's too tiny and too close to each other. So I like the space. Even this is a habit of mine. So you'll see me do this a lot, like that. That's not necessary, but I do it to be easier on my eyes. Make sense? You can develop your own habits as you go. All right. So yeah, so that's kind of the idea. This is if you guys have taken jQuery or something like that. jQuery has similar practices where you organize things to make them easier to read. All right. So let's go ahead now. Else, right? So if it's not less than 6, then 1, 2, 3, 4, print, greater, greater than 6. So you guys see that? That's basically it. All right, so let's do another example. So that was if statements. I mean, there are other things like cases, elif, etc., but you can figure that out on your own. So let's move on to the next one. It's going to be for loops. So let's do a very simple, right? So for loop for I in range, where range is basically returns a list. So you say 10, for instance. So it's going to basically iterate through 10 numbers in a range. So it does that. So then notice the colon, 1, 2, 3, 4. Print I. Does that make sense? Yeah, so we can run it now. This should work. And there you go. Let's fix that greater. All right. So that should be the easy things that, we can look at. The other things we will look at are the data structures in Python. So list is the basic one. So you should know that. You'll probably need that for the homework. We're going to look at the other one, which is dictionaries. And we'll look at the try-catch, which will be something very handy when we do things like networking, right? So having a try-catch so your program doesn't break. Sometimes you're interacting with other systems, right? So doing a port scan, for instance, means that you're sending out packets to another computer and you're waiting for a response, something like that. Obviously, things can break there. So the try-catch structure is a good one. And then we're going to get into the file system and just look at things reading in files and so on. So all the basics, basically, that we will need for managing our operating system very quickly. All right, so let's go ahead and we've done the for loop. So now, before we read in a file, let's actually see it in the operating system. So we're going to read a file from Linux. So let's do cat etc passwd. Okay, so as you can see, this is the passwd file. This is the file in the cuckoo's egg case. And basically, this is where all the user account information is located. So let's take a look. So you can see every row is an account. Not all these accounts belong to people. Some of these accounts belong to like processes in the system, right? Daemons, etc. So basically, like Telnet D, for instance, right? So it's going to be a subroutine running in the system, MySQL, etc. They're just subroutines running in the system, and they also need to have accounts. All right. So in here, at the very top, we've got the root account, as you can see. Notice that it's got an X here, which means that the password is not located here, but instead it is located in something called a shadow file. Notice that it gives you this number, which is the ID. So every user account has an ID, a number assigned to it. That's really important. And it actually has the user, and also every user has their own group. Okay, so it's going to have an associated group ID. Then it says what it is. So the name, Johnny, whatever it is. And then finally, we've got here the home folder, and we've got this. Bin bash is basically every time that you load that account, right? Let's say you SSH or whatever, it loads that program so that you can run commands. Bash is a program for running commands. It's literally like a terminal, if you want to think of it that way. So whenever you start an account and you get this terminal, that's actually what you're getting, this program bash. If you want, Linux is so nice in the sense that everything is done through a file, and basically it could be a text file. So if you want to block someone, let's say you're a system administrator and you just want someone not to have access to the computer, you can simply come in here and delete that or put a whatever in there that is in that, and they no longer have access to the bash, which means they no longer have a terminal for running. Does that make sense? So it's little tricks that you will pick up on. Because everything, as you will come to see, is a file and usually a text file that can be configured like that. Unlike Windows, which is usually like a window and a whole bunch of buttons and things. Make sense? All right, so let's take a look at, and again, a lot of these concepts will repeat as they are very central to access control in Linux. So the lower accounts are going to be root is the first one. And then the other ones are going to be subroutines that are very important to the operating system. As we move on, after about 1,000, those accounts are usually used for people, users. As you can see, the seed account and this other account I call dummy, right, are, so dummy is 1,002. Do you guys see the seed? Oh, here it is. The seed account here, which is the account we're currently logged in as, right? The one we're using has the ID of 1,000. That's the first one, first account. Every account again has its own group, and that group also has its own ID, and it is 1,000. And then you can see seed is associated with bin bash, so that's the terminal that we get. That usually is a symbolic link, one item that we saw last week, to the actual program, which could be CSH, dash, bash, etc. We'll see later on that those programs sometimes can have vulnerabilities and can be problematic. All right, and then we have here, so they need to be very secure when you build an operating system such as this. This program has to be bulletproof. All right, then you have here the home folder, basically home seed. This is where our desktop is located and so on. Make sense? You want to damage someone's account, you come in here and you change these parameters. They can't log in, they can't find anything. Got it? All right. So we saw that. So that's the file that we're going to want to read. So what I did with cat, we want to repeat through Python. We're going to want to read this file, just print it out. Things to know before we do that, we want to do ls-l. Oh, sorry. We want to do for the etc file. So we want to do for this file, ls-l. There we go. So the permissions here are really important, and this is something that we always should look at, okay? 60% of the time, your error is going to be a permissions issue in configuration and whatever it is. It's something that you need to really understand about Linux for you to be effective, right? So always look at the permissions. So you can see here, this is a file. You can see it's got that little dash here, the front. So basically it's who owns this file? Root. So it tells you that's really important because the root account owns this file. But other people can access this file, and we will see how that works later on with a feature called setuid. So it's one complicated process in Linux, but something that's essential for it to work. We've got the size of the file. This is always useful to look at. We've got the date when it was last modified. And then we have in here the permissions. So the permissions, basically the first three here relate to the owner of the file, which in this case would be root. The next three relate to group. So the group, so why is this necessary? Let's say that you all work, right, in the physics department, and you have a file called physics stuff, right? And so you all want to have access to this file. But the way that Linux works, and the files is stored in some server that you can all reach. So the way that Linux works is that only root can own the file because you can only have one owner. However, the file can also be managed by anyone in a specific group, right? So that's basically what it means. So you could then say, okay, the permissions for the owner are these, but the permissions for the group are these. So if you add this file to some group, then now you can go in. If you belong to that group, then you should be able to modify it, given the permissions of the group. You guys see that? So the first three relate to user, the next three relate to the group, and then the last three relate to everyone else in the world. So if you want to make a file that's readable by everyone, you can just put that little R there, and that's fine. The W here means write, so that means modify the file. So here, obviously, what does that mean? The owner can write to the file and modify it. What about the group? Can the group modify it? No, right? Because it has no W. And then finally, no, the rest of the world, no, they can't. So that's how permissions work. And then finally, the little X, you've seen me at that X, it's kind of the same thing. So R means read, W means write, and the X means run. Like in the classic example in Windows of a .exe file, you double click it, it runs, it starts your game or whatever it is, right? So here's the same. You have the program, you can run it as I showed you from the terminal by typing // right? So we've seen the permissions. So we know we're logged in as seed. And how do I know? Well, it says seed here, right? So I know I'm logged in as seed. I can also type ID. And if I look at the ID, if you memorize it, it'll say 1,000. So you know that. You can also ask it, who am I? And it's going to tell you who you are, right? So seed. Okay, so basically then the question is, can seed view this file? We can. Why? Because it's got this permission here. It says R for read. Make sense? So we'll be able to run it from Python. So now that we've talked about that, let's go ahead and read it from Python. So I'm going to go ahead and take a look at that script. I'm going to do basics py. Scroll down. I'm going to add a new line in here. And we're going to learn how to read a file in Python. It's very easy. You just use a function called open. And this open function can read binary files. Most of the files we're going to be reading in this class are text files. So fopen, and then we specify the file that we want. So in this case, /etc pass wd. That's the file. And we can say what we want to do to that file. So we could say, for instance, W, that it means that we want to write. This would probably give us an error initially as we do not have write permissions for that file unless we use sudo for the seed account. But all we want to do is read. All right, so that usually you open a file and then remember to close it. So you want to do f.close as well once you're done with the file. Okay, now that we've done that, let's go ahead and read the file. There's several ways of doing it. Doing this. This is probably one of my favorite. So I'm going to use a function called readLine. So basically, I invoke the object that's linked to the file, f, and I'm going to say f.readLines, like that. And that's it. So for line in f.readLines. One thing you have to understand about Python is with everything, it pretty much returns a list. So in this case, every f.readLines is really just a list of all the rows in that file. That's essentially what it is. All right, and so now that we have it line by line, we're going to print it out. So let's do the indentation. 1, 2, 3, 4. Print line. Does that make sense? And that's a for loop. That's also reading a file. This should work. So we should expect to see the text. And there it is. See, it printed everything. It's adding a line because there's an enter in there. And the print statement also adds an enter. So if you guys want to remove it, we have to do some string processing. So, whoops. All right, so what we're going to do is when we grab line, we're going to replace the new line character. So the new line character should be that. So at the end of every sentence, there should be that character, even though we can't see it. So we want to remove it from the line. So we can say probably line.replace, and we tell it what we want to replace, which is that with what. So in this case, it's pretty simple. It's just add nothing where we see that. Does that make sense, guys? Any questions? All right, so let's go ahead and run this. Maybe. Let's try that. Line equal line replace. There we go. That makes sense? So sometimes in Python, you can get away with what I did just like that. But essentially, as you saw, but sometimes you can, but for the most part, this will work. This is the default behavior, I should say. Got it? All right. Let's keep going. So we did that for loop. Printed lines. All right. So sometimes when you're doing, do you have a question? Yeah. Sometimes when you're doing scripting, you want to pass values to your script. All right. So we're going to do that now. This is called the sysargs. This allows us to use another library called sys, which is also very useful. I'm going to do import sys for system. Okay. And just going to start doing this at the top here. So this is straightforward. We're just going to read a variable that we're going to pass through the command line. And so we can do A equal sys dot arg v, and then here we specify which value we want. So actually, what we run in the command line is several things that are returned as a list. So for instance, let's do 1, right? So now I'm going to do print A. Okay, we just want to see what that is. So let's go ahead. I'm going to do a clear here. So this script expects a parameter, right, from the terminal. So if I run that, see it now gives me an error because I didn't pass anything to it. Do you see that? So instead, what I needed to do was do something like that. Now I'm passing a parameter to the script. So notice it doesn't give me an error anymore, and it should have printed the 23 that I passed to it. Do you guys see that? So you can also do I just printed it. You can see here, I just printed it. We can pass 2 parameters, but then we just have to change the index to 2. You see that? So the second parameter. So now I'm going to run the script, but I need to see if I do this, it gives me an error once again because it was expecting another parameter. So I'm going to do hello, and that's the parameter now 2 because it's the position. This should be 0. This is 1. This is 2. Okay, so, and you can see at the top it printed hello. Got it? Yeah, go ahead. Yeah. I need it for the argv function, so let me do that. See so I imported sys, and then I'm using sys here, sys.argv. So that function allows me to get the parameters from the script. Does that make sense? Yeah. Sure. And these scripts are all on the GitHub file. All right, so then I'm going to put 0 here. So that should be the script name. So let's take a look at that. Clear. Right, and let's go to the top here. And you can see it's actually the script name, basics P1. That's that there. All right, so argv. So this can be useful sometimes. You know, you have a script, but you need to modify it on the fly as you're typing the script. So that's a way of doing it. All right. Let's keep going. So we've done the for loop. We're almost done with this. We'll start to do something a little bit more fun soon, but all right. So the last thing is I do want to cover some of the data structures that you might be needing, like lists, etc. All right, so a few other things, I guess. So let's take a look at the interpreter itself. So although I wouldn't recommend doing things like this, you can sometimes just to really quickly check on something, you can just type Python and it's going to open an interpreter itself. So basically this you can run a Python code on. So for instance, I can do m equals 67, right? And that's in memory now. So then if I do M, it prints it out. And then if I do 3 plus M, and you can see it gives me 70. So this is a way of running what is called a Python interpreter, essentially just for debugging, kind of like seeing if something will work. If a library has been installed, right? So if I wonder if this library is installed, import torch. So you do that, it's not, right? But is sys installed? Yes, because it worked and there were no errors. So this is something you can do. Then you can exit out just by doing that. And you go back to the terminal, okay? All right, so that's one thing we can do. Talked about variables. All right, so let's do a list. So at some point, we're going to do a port scanner, which is, a very simple thing, right, to ping and things like that. But let's imagine that we want to create a list of port numbers. So I'm going to create a list. I'm gonna do a new script. List or data structures .py. Okay. Python. Let's do import OS for now. All right. So let's create a list. Let's call it ports list. And that's it. That's how you create a list in Python. It's used to square brackets, and then the curly brackets are going to be associated with dictionaries. All right, so we've got the ports list. It's currently empty. Let's add a few port numbers in there. So the way to do that would be ports list, list dot append. And what's a good port number to add? Port 80, right, from TCP. So we're going to take a look at that. Okay. So let's add port 80 exactly. Okay, and then let's add another one, ports list dot append, port 22. And let's add another one, ports list dot append, port 443, and so on, right? So now we've added a few ports. Let's print out the list. So print ports list. That's the whole list. So now Control X, Y, enter. Actually, it's just data structures.py, right? Run it. Yeah, I have a typo maybe. The what? Well, you don't need that one when you're just running it through Python. But if I made it executable, then yes, you're completely right. Does that make sense? So that's only when you make the script executable and then you run it through that /. Think of it as it's simple. So think of it this way. You're running it, right? And you're kind of you didn't tell it to use Python. So you could have a bash or you could have Perl or some other scripting language. So it doesn't know what to use. It doesn't know what language it is. It's not smart enough. But by you adding that line, you're telling it this is Python. And that program that can understand it is located in the bin folder that I just told you. So that's why you do that. But right now, I'm using, see, I type here Python, or you guys, I think, are typing Python 3. I could also type Python 3. Here, it's just I already installed Anaconda. Make sense? Questions? Pretty easy, right? So yeah, so Python data structures. I'm going to tab to autocomplete, and there we go. So my list has 3 port numbers basically, and that's a Python list. It's a very useful, nice thing to do. Now, what are port numbers? Port numbers are associated with services. That's actually probably our next week's class. Linux is a operating system. We're using the desktop version, but you could also be using the server-side version. And that's going to be, the purpose of that is going to be what? Running services, right? Running a web browser, an email server. At the end of the semester, your project is something like that. Configure an email server on Linux. Every service is essentially associated with a port number. So what that means is, there's a process in the operating system running, but it needs to communicate to some kind of a channel, right, that allows data to come in and out. And that's usually a port, right? So, that combination is usually referred to as a socket. And so port numbers are the processes. So we will learn next week that port 80 in Linux is Apache 2. So when you start the service Apache 2, a port 80 is open and associated with that. And so data can flow in and out. 22 is what? What service is port 22? You guys know? This is at the heart of cybersecurity. SSH, yes. So there's Telnet, which is a channel for communication, but Telnet is unencrypted. It's insecure, whereas 22 is pretty much the same as Telnet, except that it uses encryption, right? So for those of you that already took encryption, so TLS, SSH, and then 443, what is that port number for? 443. Yeah. HTTPS. So yeah, so HTTP is port 80, which is the protocol for web, right? But it's unencrypted. You also want to encrypt your data. If you log in with your username and password, you don't want that to get stolen, right? So then that's going to be 443. HTTPS. That could be a project at the end of the semester. Configure HTTPS and create a web server on Linux. You see where that's going. All right, so anyway, so we're going to be covering services as we go forward. But today, we're just thinking of how to script all of this and automate. So this is then, now that we know this information, we want to create maybe a dictionary that holds this information for us, right, in Python. So let's go ahead and do that. Let's go back to data structures. And creating a dictionary is pretty straightforward. A dictionary is also a hash table in Python, which is a very fast data structure. All right, so let's call it services. Services, and it's going to be basically curly brackets instead. That's essentially the trick. And then we have to have this thing called key value pairs. So I'm going to do a key value pair. So the structure is going to be like that. Then another key value pair like that. You see that? So for instance, let's do FTP, which is the file transfer protocol, FTP, and then that's going to be port 21. You see that? So in your operating system, port 21 is FTP. So now, let's say that you're doing something and it's an FTP service, then you can look up that the corresponding number is 21. Let's do another one. SSH, as we discussed, so that's SSH. So we already established that the port is 22. Now, I'm writing them as strings, and that could be fine, but since they are numbers, essentially, you can just also use integers. It shouldn't matter, really, as we're not going to be doing any math operations with these. They would be used basically to do networking or something like that. We can add another one, and I mean, we can continue adding like this. Let's add HTTP here, basically. And that's going to be, your port 80, and I'm missing the single quotes to indicate that it's a string, and so on. Does that make sense? So we got our dictionary. Now let's take a look at, let's just read one. So I'm going to say services. And I want to know the number for HTTP. Just like that. So we're going to print it. So let's go ahead and print this. And there we go. So the number is 80, HT. And we're able to find it by a key. So we have key value pairs, and that's it. All right. Any questions? Yeah, sure. All right. So I think that's kind of all the background. The last piece is to do the try catch. We're going to do that in the context of our first nice example. So I think we're going to do 3 interesting examples. One is going to be, let's see, the socket example. So we're going to basically create a packet, interact with the network. We're going to do one where the commands that we type on the terminal, we can also run them from Linux itself, right? And so let's do the networking one. So this is a very simple scanner or send, packets out into the network. Okay. Okay, so let's go ahead and do that. Raise your hand if you have any questions. I'll create a new script for this one, as this one will have a few lines of code basically. But let's go ahead. So I want to look at my file. So I have 2 basics and data structures. I'm going to create a new one. I'm going to call it socket example. Socket example.py. All right. We're going to use a library called socket. We have another library called Scapy, as I said, which is very powerful actually. But let's start with this one. So let's do import socket. All right. And then we create a socket by doing socket.socket. And remember, a socket is essentially a tuple, a pair of IP and port number, right? And that's it. So we want to interact with our computer. We're going to set a default timeout of like 2 seconds or something. So let's do socket.set default time out equal to like that. All right. Seconds, yeah. Or millisecond. That's fast. All right. So now let's create the tuple itself. So that's going to be some IP address, right? We can change it later. I'm just going to put in something, placeholder, if you will, but in the right format, right? So I'm going to do IP address equal in double quotes 1.1.1. So we can always use like 8.8.8.8, which is the DNS server for Google. All right, and then the port number, let's just as a placeholder now, let's just say port 22. We can change that later, something else, as we try to get this to work. All right, so remember I said I'm going to use the try catch here to motivate. So try catch is you run a piece of code in the try. If it doesn't work, the program doesn't halt. It just says, okay, there was an error, and that's a nice function, especially let's say that you were pinging a whole bunch of machines and, at 100 machines, right? It's taking a lot of work, and at 50, it kind of breaks. So it would kill the whole program. Whereas with this approach, it won't. So in Python, this is, all programming languages have this. So in Python, you just do try, except, and then you specify, uh, except, you can just do exception. Oops. Like that, and then colon. So you need to provide what the code is for try and then the exception. So let's write the exception in here. Remember indentation, 1, 2, 3, 4. Print. You can say there was an error. Okay. But the program will continue. So I can do, for instance, print 7, and the 7 is still going to print even though there was an error in the program. Do you have a question? Yeah, go ahead. Yeah, I think you can do something like E, for instance, to hold a variable and then possibly print that. So we can try printing both of those. Sort of like that. There may be several errors. I mean, several variables that provide information as to what happened. Does that make sense? All right, great. So what do we want to do? Let's connect to some IP. Okay, so now we're gonna do in the try itself, 1, 2, 3, 4, s dot connect, and we provide our socket, which is in Python another data structure called a tuple. The basic idea, a key value pair, right? So or something like that, and this just two items that go together, and they just happen to have a name called tuples. There can be tuples of 4 or 5 items. It's just sometimes that's actually easy or easier when you're doing things. So in this example, it's going to be IP address. Okay, and then the port number. You can just say port like that. That's it. Everyone with me? All right, so IP address and port number. So we connect. This essentially in the background is crafting a packet and sending it out into the network. Okay, so you've literally created that. 1, 2, 3, 4. A lot of this, when you're, if you're not just managing this computer, but managing other computers in the network, is going to be through network packets. Once you send the packet, you're going to wait and you're going to try to receive an answer. So if we were doing ping or something, so obviously we're sending a packet and then we're getting it back, right? So that's what we're doing right now. So I'm going to do S. Answer is going to be equal to the same S, the same object, which is kind of basically, think of it as it opens a port and it's going to wait for an answer, a returning packet, given the time window. So I'm going to say here dot receive. And we specify the amount of information for the buffer to receive about 1024 bytes, which should be enough for what we got it, guys. All right, so yeah, that should be. And then obviously we want to print the answer to look at it. So now we just have to find a computer that we can ping, right? Maybe the Google DNS server. Obviously, if you did this thousands of times, it's a denial of service attack. So be aware of that. All right, so that's it. So let's try it. So 1.1.1, I think this is an actual company nowadays, a domain. So let's go ahead and try that one. It's only one packet that I'm sending. Let me do it first. See what it returns. Usually this has a name. but we usually we can get the banner of that system on that port number, and it was 2022, which is SSH, not the web of it. So let's see what happens. Okay, so I have a syntax error. Take a look. Let me remove that E from it. Let's try it again. Okay, no error this time. It said there was an error, so it didn't get the response from 1.1.1. I don't know why. So it could be something as simple as the network does not have port 22 open. You guys see that? We don't have that information. So this is not smart enough yet, given my simple coding, that it doesn't give me that information. But let's take a look. Let's change the port number. So what makes sense is to change the port number. Maybe I didn't find the IP. So port 80. Let's try that. 80 is more likely to be open on a server, given that it might be a web server. I don't know. Okay, it's not liking that. Let's do the DNS server for Google. There was an error, class exemption. Well, let's just do the local host, actually, what I was going to say. Let's start there. We know for sure we can get access to this computer, right? So what's localhost? Right? And then 1, is it? Yeah. Right? Localhost. Right? All right, great. So let's go ahead and try that one. So, we're debugging the code. It could be many things, but we're interacting with an outside machine, so we definitely want to take a look at that. Error. Now, is that port open on this computer? Port 80. How do you know? Yeah, go ahead. Probably, but how do we actually know in the operating system if a port is open or not? You see what I'm saying? Yeah, services. Yeah, so that's a good one. So I'm going to give you the command. This is one of my favorite commands, actually. So write it down in your cheat sheet or wherever. It's called netstat command. And there's a lot involved here that we're going to cover later on in the semester. But we use the netstat command, and then we provide the flag -NA, and this will provide an output. But it's a lot. You see that? It's hard to read. I don't need all this information. I'm only looking for something very specific. So what I do is I need to filter it further. So in Linux, you have this the command prompt pipeline, which is really nice because it allows you to pipe output from one command into another command. And this pipe, there's actually, if you didn't know this already, on your keyboards, there's usually a symbol called the pipe, and it's a straight line. So let's do that. So now the output of this, I'm going to pipe it into something else. So that's this over here. Does that make sense? And now I'm going to move it to something else. And I'm going to use another command in Linux called grep, which we will explore later in the semester. This one is really powerful. Is a filtering thing. So it allows you to say, okay, from this output, just look for this specific thing and return it for me. So what is the protocol for port 80? Port 80 is TCP, right? So I'm going to say grep anything that contains TCP in it. So essentially, this gives me all the TCP ports that are open in the network in my computer. None, apparently. You see that? What about UDP? Okay, there's a few in there. Okay, Oh, TCP. Let's try it lowercase. Okay, great. So you can see I now can totally see everything that is open on this computer that is either TCP or UDP. So I was trying to ping or whatever, trying to reach port 22. Oh, no, sorry. Which port am I trying to reach? Port 80 is what I tried to reach in this computer. So what we need to do is this is the information for UDP. This is the information for TCP. So I'm going to look for that port 80. So do you guys see it? So it would be port 53 or port 22, port 631, port 2325. So I don't believe it's open, right? So this is not, there's no socket there. So, but I can see that port 22 is open. You guys see that? So we should be able to use our script for port 22 localhost. Yeah, go ahead. I think so, yeah. That's a good point. Let's see. If not, we're going to start it, but I think so. Let's go ahead and do that. So let's dash L, right? Let's go back to the script. You know, so let's change it to port 22. Okay. Run it. And maybe it's something else that's wrong with my code. So we're definitely trying to debug it. Ah, but it is open and it worked. Do you guys see this? It returned. This thing is sometimes called the banner. Yeah, the banner of the service. Sometimes it has like a little, it gives you the title of the system of the program. So in this case, it's telling me what? My computer has port 22 open and it's running SSH 2.0, OpenSSH 8.2 P1 Ubuntu. I actually got a lot of information, right? If I'm a hacker, I know, for instance, oh, okay, I know for sure that this version of OpenSSH in Ubuntu has a vulnerability. Guess what I'm going to do? I'm going to attack it. If it hasn't been patched, I'm going to be lucky. So sometimes this can be called fingerprinting, whatever, but it's just an example of our script. We used a try catch. As you saw, it was failing quite a bit, but it wasn't breaking, right? And we were able to send a packet out to port 22 on this local machine and get the result. Now, this should work on any computer. I just need a computer that has uh, port 80 or port 22 on the net on the internet. I'm trying to think like what computer that would be. Web, okay. Let me ping my own website. It's hosted in the cloud, but see, there's the IP. Okay. So that means port 80 should be open, right? That's a good indication. Port 22. The IP. So now let's go to the script and change the IP to that one. Now, some servers will have firewalls and things like that that might filter these things. So I don't know what's going to happen. I use GitHub to host my website, so I don't know what kind of security they have. But let's try it. Whoops, not that. So it didn't let me. You see that? So it doesn't like it. Uh, let's try. And you guys can try other websites that you know, and if you can find one, PNW, for instance, may not care. Right, so they're using 128. Okay, let's try PNW. Let's switch it over. What do you guys think? Have you tried any other websites? Yeah, something easy that's not very secure. Um, this, okay. So it could be the firewall here, could be lots of things. You can try this at home, for instance. That may also work. All right, let's give this one last try. Something that is very public, like Netflix or you want me to ping that? Scan me. Mhm. .nmap.org. Okay. Did I spell it correctly? Scan me that. Try Wikipedia. Just I'm looking for something pretty public. All right, we'll give this one last shot. If not, we're gonna move on. We'll come back to these anyway, these ideas later. There. All right, so yeah, for whatever reason, they don't let that anymore as a security precaution, most likely. All right. So yeah, so that's a simple example of using the socket library to create some packets and basically doing a little bit of scanning. All right, we have 10 minutes left. So let's go ahead and oh yeah, so I need to do functions also. Let's do a simple function. So in this case, I'm just going to modify this code to have a Python function. So I'm going to do define scan sockets colon. Okay. And then we're going to provide basically the IP address and the port number as arguments to the function. So basically this code here would now go in the function. So we can probably just copy it. Remember indentation here. 1, 2, 3, 4. I'm going to do paste. There we go. So we've added the code. And then now here, instead of having this, we just call that function. Leave this in there. And the function is now scan sockets. Underscore sockets. Whoops. Just like that. Okay. So that is our, essentially our, creating a function here just by moving the code and rearranging it. And that shows you an example of how to do this in Python. So you might see me do this from time to time. This should still work. I'm just going to try. I don't remember the port number for UDP. I know, I believe it's UDP. Let me look it up. $53. Let's see if that helps. All right, so Control X1. Yeah, still giving us the error, but we can see the function did not error out, so that means it worked. Right? We'll use more powerful libraries than sockets, so we'll move on to the Scapy library, which should give us more versatility. All right, so I think that's all the background on Python, kind of the review. So now let's take a look at, we've done sockets. Let's take a look at another, let's kind of wrap up today. And I'm not going to give you a homework yet for this since we haven't finished this. So we'll finish this next week. All right, and then I will assign the cuckoo's egg once everything is completed. But let's look at subprocess now. So it's a very powerful function. Okay, so let me take a look. Yeah, so this is, I'm going to create a new script called run commands. Nano run commands.py. And I'm going to introduce a new library called subprocess. So this is really nice. So anything that you can do on the terminal, you can do in a Python script using this library. So for instance, we're going to do ls-l, but instead of doing it here on the terminal, we're going to do it through a Python script. And that you can see how it starts to lay the foundation for automating system administration. All right, so let's do that. So once we've imported the library, all we have to do is call the library subprocess. And you can sometimes achieve some of these things with sys and os as well. So subprocess and then dot call. And we provide our argument, our commands as a list. So we're going to say, square brackets, that's the list. And then the command is ls. And then we specify any flags like this. So dash L. So ls-l basically that we were doing before on the terminal, we can provide as a list essentially. Do you guys see that? The logic? So now let's run it and test it out. So I'm going to do run commands, but I'm going to run it through Python. And there you go. See, the output is exactly the same as if I had typed ls-l. So hopefully this shows you the power, because with this little 2 lines of code, any command that we can type on the terminal, we can run through a Python script, and then we can start to automate lots of things. So you can imagine how ChatGPT, we could bring ChatGPT, talk to it, and it can start to control things, for instance. So, and so on, right? So right now we're doing everything manually. We were writing the scripts, but we know nowadays, these LLMs can even generate code. So yeah, more automation, if anything. All right, anyway, so that is the example using subprocess, just so that you guys get a feel for how it works. Obviously, we'll be using this a lot throughout the semester, seeing more examples. All right, so I think this is a good stopping point. As I said, no homework today. Just finish what you guys were working on from last week, which is due Sunday, I believe, right, at the latest. But it's due tonight. So just, submit it. And we'll continue with this discussion next week, right? And then I will assign the homework, such as the cuckoo's egg. Yeah. Was that in this module? Really? It's not here. So where is it showing? Really? I have not posted any grades. I thought I got rid of all these. This is probably, yeah, so this Wireshark 2 is from last semester, and it just got stuck there. So I deleted all the other ones. I'll delete this. It shouldn't be there. Okay? Does that make sense? Sometimes when I copy every semester what I did last semester, and I think this copied over. So I'll get, because we will do a Wireshark, but not right now. I haven't covered that. Okay? All right, I will end the video here.